What's up, everybody? How's it going out there? So I have a machine that was just dropped off, and this is an Atari All Points bulletin. And needless to say, there is a bunch of stuff inside here. It's really dusty. That I'm going to have to spend some time on and verify that everything is okay. Some stuff looks like it wasn't even put back together the way it was supposed to be. And then we've got a lot of ICs right here. We have tons of ICs right here. And I'm dreading that. Okay, I gotta tell you, I'm dreading that. So I got a lot of stuff here I gotta look at and verify. But the first thing that I'm going to do is I'm going to see if this monitor is good, and I'm going to try to rebuild it if I can. Not the tube, obviously, but over here, this is what we have that he had brought with him. And so one of the first things that he showed me was where it kind of looks like there's some glue or something down here, or something was leaking. So these capacitors I'm going to end up popping out, because this one looks, it almost looks like a glue instead of a leakage, but I'll find out. We're going to pop all of these dudes out of here and see what we can find and replace what we can. So this is 22 by 50, and put this in C13. The first capacitor that I took out I had replaced. I found one that fit that. During the time that I'm doing this, though, I saw something that was interesting, and I'm not completely sure if this was just the way that it was at the factory. So I'm going to have to try to find the schematics for this board here. But let me move some of this shit over so you can see what I'm talking about here. Right here it says C7, but there's nothing there, but it's been soldered over on the rear. And then over here I also noticed there's like a C58. I don't know if this board was used for a number of different things, and just depending on what it was going to be used for is when they decided to put those in, or if somebody had worked on this, which apparently somebody has before I did, and they took that out and they just never bothered replacing it. Now, because of the shape of it, it would tell me that this is probably a polypropylene. So I have a hard time believing that somebody would have taken that out, because most people only replace the electrolytics, because that's really the only thing that they know how to do. So that might be just the way that it is, you know, from the factory. So from here, we're going to work on this one. And I know that this is a little boring, guys, but this is a lot of what you end up doing when you are troubleshooting old games. So right here there's some discoloration. It looks like there's been some heatage. That's not even a word. It looks like there's been some heat or something right there on that thing. It might be nothing, but I'll examine that. And there are tons and tons and tons and tons and tons and tons and tons, and it just keeps going. This is going to keep going until we reach the pits of hell of ICs. There's some things down here that have been kind of spliced together that, and it looks like there's like a wire that hasn't even been attached. It kind of concerns me, the way that this power supply and everything kind of looks. There's a fuse down here that's missing with nothing hooked up to it. Man, my sinuses are driving me crazy. The first thing I'm gonna have to do is clean this damn thing. Because I need to know what the hell's going on. Now, this is a soundboard. I'm almost positive that that's a soundboard. We have our power supply. Down inside here controls the accelerator. I have the parts for the monitor. Those were separate from the rest of the machine when he brought it. So I started working on that last night, replacing all the capacitors and stuff like that. And there were tons of capacitors on it as well. So during the time that I'm waiting for some of the capacitors that I have ordered, because I had a lot, but I didn't have all of them. But during the time that I'm doing that, I can
I can check the power, make sure that that's good. I can check the soundboard, make sure that everything's good there. I can look for cold solder joints here. If I have to replace all of these sockets for these EPROMs and RAM and stuff, this is gonna be murder. I'm hoping I don't have to, okay? But I can check for cold solder joints. I can check for a lot of stuff, just making sure everything's kosher before I actually turn this on, because I want to have the monitor working before I really actually turn it on, because I need to know what is going on. Kind of looking at everything here. I'm gonna have to go over this with a fine-tooth comb. I'm gonna have to check pretty much everything that's on here. But I want to make sure that we have a tube that works, okay? That, in other words, I'm not trying to fix something when I have a damaged picture tube. And if we look at the neck board here, if you look on this side, okay, you're going to see numbers 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. Okay, and right over here, of course, we've got one right there. Now, we also have 3 transistors, and you're going to see that these transistors, also with a resistor, goes to one of the backs of these. Okay, it always does. So what we're going to do is we're going to figure out which ones of these actually go there, and after we do, we are going to. Is this supposed to be there? I think it is. Okay, but as soon as we figure out which numbers, which one of these we go to, that we're going to ground it, and if the tube is okay, we should end up seeing the screen basically turn that color. Okay. Now what I've done is I have printed out the schematics for this particular monitor, and this is our neck board right here. Okay, let me get a little bit closer so you can see what I'm talking about. So here's our transistors, and these are going to be basically our drivers for these colors, okay, that show up on the thing. Now we're seeing red, okay. Now you're going to see that one lead of the transistor goes up to the red, shoots over. This says goes to number 6. This one says number 8, and that one says number 11, okay. And even if it's not numbered, we could just follow the transistor, right? So whatever, because there's only one lead that goes to the tube, right? There's only one lead of the transistor that actually goes to the tube. So you follow that, and we'll be able to figure out if this tube works okay, like if the tube is fine. Because like I said, I don't want to be working on this only to find out it's because we have a bad tube or something. Okay. So according to this, 6, 8, and 11. Okay. And if I look at this, there, it's written here, you know. So we have 6, 7, 8. So 6 is right here on the side. Sometimes it's actually written, you know, sometimes it'll say R or whatever. But so when this goes back up, this is 6, 8, 9, 10, 11, according to this, okay? So here's 6, 7, 8, 9, 10, and here is 11, okay? So according to that, as long as I ground one of those one at a time, we should be able to see something on the face, on the front, and we should see changes. So we've got this one, 6, 7, 8, 9, 10, 11. And when doing this, you only want to ground really quick. You don't want to hold it there for until, you know, Jesus comes back. So I've got my grounding clip, my alligator clip. I'm just going to clip somewhere onto the frame here. And I can hold it like this and then just touch it like that. Or I can attach a screwdriver to this just to make sure that I've got a little bit more distance between me and any type of potential nasty voltage. Okay, so I'm going to have a hard time seeing this, so I'm going to have to record it and then revisit what I have filmed. If you hear me scream during the time that this is happening, you know it didn't go accordingly. So here we go. Turning it on. I'm getting my neck glow as always. And I'm getting my red image with a little bit of green down here. Okay?
Actually, I'm seeing red and green. There's something definitely weird. Okay, but I want to make sure it's not bad too. So I'm going to touch 6. I'm going to touch 8. And now I'm going to touch 11. And I know, just from what I saw on the reflection, that I got something on all 3 of those. Okay, so that tells me my tube is okay. My tube is fine. What I'm going to do is, one of these is focus and one of these, this is the flyback that I'm turning down right now. Okay, the flyback is completely turned down, and I'm going to start turning it back up again. I can see the raster lines right here. I can also see that it kind of gets bigger. Me adjusting this horizontal, you'll see that we're getting a difference in brightness, right? As I turn it up, it goes down. As I turn it the other way, it gets brighter, okay? And that's because the horizontal and the flyback have a symbiotic relationship. If one goes bad, generally, that's how you can tell. I'm turning the flyback down again. Keep it right there. Where I can just barely see a little bit of these lines. Because I'm going to keep adjusting this stuff until things might look right. I have blue down here, yellow up here. To me, it's like screaming like a gouging issue or something. I'm not. That's kind of strange. But the yolks can also the yoke can also do this. The convergence rings. Now that I have turned that off, if I go in the back and I try to pop the voltage basically out of the picture tube, in other words, I'm trying to discharge it. Okay. If I come back here, so you can see what I'm doing here, it won't pop. Okay. And I'm going to explain why here in a second. But right here, I'm going to go ahead and I'm going to ground this. I'm going to take my little screwdriver here, and if I stick it under, we won't hear a pop. And I'm touching the leads. We don't hear a pop, okay? That doesn't mean the flyback is bad, okay? Because some monitors actually have a, I don't want to call it a device, but some of them have a circuit that discharges the flyback when you turn it off, okay? And it's just a safety precaution, and it discharges it. And that's pretty much the reason why this is happening. That is not a sign of a bad flyback. I tried to get as much of the dust out of here as I could with my Dyson. I might have to end up getting my shop vac to do even better. But there's all sorts of problems, man. There are all sorts of problems with this. Because down here, I don't know if let me see if the camera's going to pick this up. Down here, no it's not, you're not going to be able to see it, okay? But down here, you could tell where there was stuff that had been melted. You could tell where stuff was spliced. It's just bad, man. And so I have no idea what the hell is going on down there. I'm going to end up having to get the schematics out and make sure that all of this is wired correctly. I'm going to have to trace a bunch of stuff, making sure that it wasn't damaged from the past. I mean, originally I was told it was just like there was a graphics issue. That's what I was told originally. But it goes way beyond that. It goes way, way beyond that. And this is going to be a headache. It can be fixed. Anything can be fixed. But this is going to be a headache. But first things first, I'm gonna take this monitor apart again and really go through these boards with a fine-tooth comb. Look for shorts. Look for anything that I can find wrong. There's some things I don't have to really look at, like the flyback and stuff. We know that that's good. The horizontal stuff we know is good. You know, the caps had been replaced, so those are good. You know, we're gonna have to look at certain things, but take all this stuff apart. After I know I got the monitor where it's good, at that point is when I'm going to start doing the power supply. Power supply is going to be next. And then I'm going to make sure that it's wired correctly. And that looks like it needs to be repinned and everything because it's toast. But I'm going to check all that, and I'm going to make sure that we have a continuity between all of our wires and stuff that are going to different parts, like the audio and stuff like that. We got grounding stuff over here that's like missing. There's just all sorts of shit over here that I'm just like, what the hell, man? And then after that, I'm gonna have to start hitting these boards. So when we've got our resistors here, if you don't have the schematics, how do you know what number you're supposed to be getting, right? Well, there's a code, a color code, and it basically is like this. So you start with black, then it goes to brown, then it goes to red, then it goes to orange, right? Then it goes to yellow, etc. Green, blue, violet, whatever. And each one of those is equivalent to a number. Black is 0, brown is 1, red is 2, that type of stuff, right? And so what we're going to do is, if we look at this, and the first band that we see is red, so we know it's 2, and then this looks like it's violet. Could be blue, but it looks like it's violet. So that would be the next number, okay? And let me write this out so you can kind of see what I'm talking about here. So we have 0, 1, 2, 3, 4. Okay, that type of crap. And then we're going to go black, brown, red, okay, orange, yellow, green, blue, and then right here we would have our violet. Okay, so 7. Silver is, I believe, 5%, and gold is 10%, I believe. All right. So this is basically saying 2, 7, and then we end up having another red on here. That's the multiplier. So we have 27 and 2, so 2700. Okay, 2700 is what we're supposed to be getting, and then we have a silver band that tells us the tolerance of it. And then so if we come over here, we should see something pretty close to that. We're getting 2302. Okay, that's inboard. 23. Let's come over here to this one, and because this is the same, we're getting a 257. So as far as the tolerance goes, the tolerance on this is a little lower than it's supposed to be, right? I mean, this is saying because 2.3. Now this also might be finding another route there, right? It might be, but that is considered a little low. But let's just say 5% of that. So yeah, it would be considered, this resistor would be considered out of spec. But like I said, there's a possibility that this is not just going from here to here. I'd have to remove this to verify. I actually have this reversed. The silver is actually 10%, and then the gold is 5. So, and then just to make this complete, we'd have gray, and then right here we'd have white. Okay, just to make that complete for you. But I have these reversed. I thought something didn't look right when I was saying that. But most of the time I'm dealing with gold. So if we come over here and we test this, so we have basically 10%. And if that's the case, that's 23. So that would be 25.2. Okay. And once again, that's really still too low. It's still too low. Unless it's supposed to be 25. This might be blue. This might not be violet. This might be blue. It's just really hard. It's just really hard to tell. This might be blue, and if that's the case, then it pretty much is close to what it's supposed to be, right? If it's blue, if it's purple, it's not. But because these two guys are closer to 25, 26, I think that this might be I think this might be blue. I'll have to check the schematics. So I've got these transistors here, and I'm going to be testing them using the diode setting. The middle post is the same as this. Okay, so I'm going to start with my positive over here. Okay, right here. Okay, now I'm going to flip these guys. I don't get anything. I don't get anything. I don't get anything. Okay, same thing. This is what I did. Positive on this side, and this will change the P and P and P and. All right, so we got this. Nothing. Okay, so we'll come over here and we're going to try the same thing with this one. So far these are testing okay. So I'm going to continue doing exactly what I was doing on that neck board, except just here. There's going to be some things that chances are they're not bad, you know, because it's rare that they ever really go bad. Things like, you know, coils and things like that. A lot of times these types of film capacitors, and you don't really have to worry about it. You know, these types of resistors, these high wattage resistors, a lot of times they don't go bad. So, you know, checking the obvious resistors, you know, I'm going to look for anything that looks burnt or anything like that, because I'm not going to test every single resistor. I don't think that, I'm only going to test the ones that look like it's a potential problem. The caps, I've replaced all of them, so I know that those are good. Yeah, I'm just going to kind of go through and systematically look at everything, and transistors I'm going to definitely be looking at. But as soon as I'm done with all that, I'll turn the camera back on. So I've removed the boards from the cabinet here, and you'll see that we've got some pretty serious burning on this, and also we can see that there's wires just like simply missing, stuff that's been just twisted together. These two I had to cut because I just couldn't pull that other Molex connector off because it was melted on there, it was burnt on there. So these wires, there's stuff that's definitely wrong with them, so I'm going to have to get the schematics and trace those and make sure that this is done correctly. I'll probably repin this. So where these come in from the power supply and off to other things as well, I couldn't even get this piece off right here. Look how burnt this is. I mean, it was just completely burnt on here. And then there was also another one near the top that was completely burnt like that. And somebody had really rigged those wires up. So what I'm going to have to do is I'm going to have to kind of trace some of this to see if there's been any damage from this point back, you know, at least for the first few components, to see the most sensitive ones and see if anything has been damaged. And hopefully it hasn't been. Hopefully it just was right here. We do have some, looks like those are some capacitors right there, so I'll have to test those, because that's first, and then right after that looks like we have some transistors. I'm not sure if they're part of the same circuit. So if we look at this, it shows us the wires, and somebody had messed with those wires inside there, so I'm going to try to make it right. And if we look at this, we're going to end up seeing, let me do this so you can see better. If we look at this, we're going to end up seeing some stuff. We're going to see, here's our triac. This is basically coming off of the power supply right here. Okay, right here is the power supply. And this has got the color codes, right? So we got a red and white, red and yellow, etc. And this shoots on over, and it says this goes to the video PCB. And what we're going to end up doing is we're going to end up making some Molex connectors. We're going to end up making some new ones here. But this, we got this one that shoots on over here. We got a couple that shoot on over here as well. and we're going to have to pay really close attention to all this and try to make sense of what we have inside there, as well as what's here, because what's inside there is a mess right now. We have to basically rewire it. So I've got my new Molex connectors, and here in town, there's a place called Willie's Electronics, and you basically buy the Molex connectors like this. I ended up buying a whole bunch of different ones, so that way I don't have to go get any more anytime soon. But yeah, so let's go ahead and get started on those wires. So I've taken the power supply out. It's covered in dust. I'm going to take this out in the garage and use my air compressor and blow all the air off of this. But this portion of the switching power supply, I opened it up, and then we got a nice bulging capacitor right there. I'm also going to end up spraying this out as well. But I suspect we have some problems with this power supply, and this guy right here needs to be replaced no matter what. But I want to check all this stuff out really well before I put this back in the cabinet. Okay, so cleaned all the dust out of here, and looking at these wires, a lot of this stuff is really bad, but I'm gonna take this piece out, and then we're gonna remove this capacitor, and I'm gonna test these other ones. I'm gonna see if I can test them while they're in circuit to see if they're okay. So one of these is 3300, and of course there's going to be a tolerance there. We're getting around 29, which isn't really, we should probably replace this one. Now, if we look at the one that had the pop top, the dome on it that's a little popped here, also you can tell the color of it. There's something that's not right about the color, right? So let's hook that up. Okay, we have that hooked up, and this is what we're getting with the capacitance. So this one is definitely toast. Okay, I mean, it was obvious just by looking at it. So we're going to replace that, and even though you might end up getting a good reading on these, this one's going to get replaced as well, just because of the way it looks on the bottom, and it's old. Might as well do that. But even if you get a good reading, it doesn't mean that the ESR is any good. And then so you need like a different meter to test the ESR, which is basically is like its resistance, right? Okay, so after taking it apart, messing around with some diodes and transistors and stuff, I think we got the problem fixed. Let me untangle my damn wires here. Alrighty, so let's go ahead and put this guy back on DC volts so we can measure some DC here. Let's turn her on. Let's hope it doesn't blow up, right? Okay. Once again, we'll come down here. We'll test the 5 volts. And then this can be adjusted by this little knob up here, which is it's a voltage regulator knob. Let me just find the slot for this thing to go into right there. And you'll see I'm turning it up. I'm going to go right there. Whoops. Yeah, that's close enough. Alright, so we got that. This right here is ground, so we should get nothing. This one right here is negative 5 volts. Negative 4.1. It's a little low. Right here is positive 12. That's pretty close. I wonder if this will actually adjust that. Yes, it does. Okay, so all of the power supply wires are where they're supposed to be. It's been repinned. I've checked all the voltages. Everything seems okay. I've hooked the board back up. Okay, and I'm a little leery about a couple of these points, a couple of these wires, but I might have to fool with some stuff. I might have to change some things, but I am ready to turn this guy on and give it a test run. See what happens. This is good. This is good. ROM, okay. Very good. Hey, we're on to right here. We're on to something here, buddy. Okay. We've got a problem with this. Okay, so instead of taking the monitor out, I decided just to put a mirror in front of the machine and try to adjust it that way. It's a lot harder because you can't get your face close to the monitor, and so your eyes can kind of play tricks on you, as well as my eyes aren't the greatest shape right now. So anyway, the cutoff happens back here along with the guns as far as adjusting the RGB. The purity, where that weird blotch is coming from that looks like a degaussing issue, we're gonna control that with the first set of rings. There's 2 rings. We're gonna control it with that, and then we're gonna end up moving these other rings back and forth till they all line up, and we'll end up getting a much better picture. Now that line that you see that is cruising through at an angle, that is not here. You can't really see that. That's just because of the timing of my camera here with the TV, but that line doesn't really exist. But if you look at the bottom, you're going to see that it's kind of yellow down there, and toward the center it's not right. So what I'm going to do is I'm going to adjust the purity rings right about there. And now that's gone. Okay? So now we don't have to worry about that weird thing that looks like there's a degaussing issue. But we're going to have to set the convergence. All right, you see on this how near the edges you can see some red and blue and everything? That's a convergence. We need to move these convergence rings. That looks good. Something's kind of going on the bottom there, but I can accept it. Okay. When they're all together, we end up having a white picture. But on the outside, you can still see the red and the blue. That's a convergence. Okay, and if this is bad. So this is what we're going to be doing. This is what we're going to use to set the convergence. Okay, so let me zoom in so you can see exactly what I'm talking about. Now you see how it's like red. You can see like a red and white and everything like that. It's because one of the rings, maybe 2 of the rings are out, and so we're going to have to kind of spin those back and forth until we get all this stuff lined up as best as we can. The purity looks like it's been set. So I'm going to call the purity good. You'll see that they will kind of go at an angle to one another. So it's kind of a pain in the ass, honestly, to do this, especially from a distance. My eyesight right now is not very good. That's better. But then that messes with the top. So we're going to try to separate these guys a certain extent, at least, to see if we can maybe get these guys to cooperate with us. I was having a hell of a time doing this inside the cabinet. So I went ahead and I took the monitor out in order to set the convergence and the purity and everything on this. And much better, don't you think? Much better. So I'm pretty happy with this right here. I'm not seeing any of those weird things that look like it needs to be degaussed anymore. The colors seem pretty good. Right there, it looks like it's a little purplish. I'm going to turn down the red cutoff just a little bit. Let me fool around with the blue cutoff a little bit. I want that white to pop out. That looks a little too cool. Looks like it's got a little bit of blue in it. I think we're good. So convergence is set, and you'll see that if I zoom in, the convergence is a lot better than it was. Okay, color's done, purity is fixed. I can throw this back in there, and we can try to adjust the picture the best we can. Okay, we're going to try to get this set up right because we got some stuff up here that says demerits that isn't quite right. We got some stuff down here that isn't quite right. Okay. Let me try to figure out why this monitor is kind of doing what it's doing and it's giving me too large of a picture. So these siren lights, look at all this dust. This looks straightforward enough. Looks like it's just a couple of regular bulbs. So I'm having a problem with the horizontal width control, and the horizontal width control basically determines where this begins and where it kind of ends on here. And this side is about 1 inch or so, and on the other side down over there, you can't really see it, is about 1.5 inches. And the problem is when I turn the game on, I can see everything within the boundaries of here and here, but some of the video is being cut off from here to here, and then from down there, it's being cut off. So it's almost like there's a bezel that's blocking some of the video. And I've tried adjusting the horizontal width control, which is, it's going to be kind of hard for me to get to it. Right there, that's the horizontal width control. And I've tried adjusting it, but the problem is it does absolutely nothing when I turn it. Nothing at all. So I decided to start tracing the circuit for the horizontal width control to see if there is a problem, if there is a broken trace somewhere, if there is a bad part. And I went through the schematics here and I'm just cruising, and everything that I test, I mark it green, so I know that we're good. And right here where it's supposed to be 123 volts, I'm getting 129. It's a little high. It's a little high, but I'm getting the voltage that I need. And so right now, what I'm doing is I've got this printout, okay, of the main PCB right here. And it's got everything on here like C56, you name it, right? And this right here has all the voltages that when I test it, this is what I should be getting. So I'm going to go through and I'm going to test all of these locations to see if I'm getting the voltage that is required for me to have this thing run the way that it's supposed to. Okay, so what I'm going to do is we have our video that's coming in that is basically the red, green, and blue. Okay, so we have our video that's shooting in here, and we see that the convergence of them is pretty good, right? Because we don't see them all separate and everything, so we know the convergence is good. We don't have to fool with the rings, it looks like. And we also see that they're all on top of one another. In other words, a convergence, like I was saying. So it tells me that more than likely these 3 transistors are probably okay. All the capacitors up here are probably okay. You know, we just kind of keep following this and kind of see where it goes, and it goes into this particular IC right here for those. Okay, then from there it's going to end up going through a couple other transistors until it goes out. Now, over here we've got our vertical and horizontal sync. Our vertical sync seems to be fine. Our horizontal seems to be like it's firing a few times strangely. And typically when you have a horizontal sync issue, typically like it looks like zigzags, like when you lose all sync, but we're not getting that. So what I'm going to do is this transistor right here, because we have a horizontal sync, this is coming in from the game or the thing. This one right here might be firing a few times. Something might be wrong with this, okay? And that could be one of the reasons. But if you follow it, once again, we've got a couple of diodes. Maybe the diode's bad. I've checked diodes, but we'll double check. You know, follow this, it kind of cruises. We have another one of these transistors. This goes to the negative portion of the horizontal sync. But if you keep following it, eventually it comes over here to a 7823. Okay, so we've got this guy and we've got this guy. And that's, I'm going to be looking at these transistors first. Then after these transistors, it's these two guys. And then we have the horizontal drive and the horizontal position. We have another transistor right there. So I'm going to be pulling out transistors and testing them. Okay, so what I couldn't figure out what the hell was going on with this monitor. And I ended up taking it to a guy that specializes in monitors, and he looked at it and he said the problem is the chassis does not go with this tube. And he said this I think went to like a paper boy or whatever, but this went to something else, and so he took out the chassis and then he put it in the game paper boy, and it worked. Okay, so it's the wrong tube for this chassis, and it's not the tube so much as it is the deflection yoke. Okay, so could it be converted and everything? Yeah, I suppose, but that's a little bit beyond my skill set, because I'd have to change certain things within the chassis that I really don't know what values I would supposed to use, or I'd have to get a replacement yoke and everything, and that's going to be very hard to come by. It would be cheaper just to go LCD. So I've got my converter here, and this is the CGA and the EGA and everything like that to VGA, and that's what we're doing. And we're going to be putting basically a regular computer monitor. We're going to hook it up to this, and of course these monitors are not easy to find anymore, and you have to kind of go around to pawn shops, and you have to go to places like Salvation Army and all this other stuff, and then you can find them. And I had to find a 19-inch monitor for this to work. And because this is a medium resolution monitor, this particular card doesn't really want to work with it too well unless you find a composite sink. Off of the wires right here, you'll see that there is a yellow and there's also a gray, and this goes to the horizontal and then the vertical sink. And there is a horizontal and vertical sink that goes to the monitor, but they don't really work too well. And so it'll keep telling you that there's no signal when there actually is one. So what you do is you have to go to the composite sink. And the composite sink is, even though there's no wire coming from it from the board, I mean from like as far as like the Molex connector, the sixth one over, there's a composite sink. And then so I've hooked up a wire into that, which is this yellow wire, and I've hooked it up to the gray. So now when I turn this on, I'll end up getting a picture. But I am dealing with another problem right now. And so that is the way that it's supposed to be. But I've got a slight problem here. And the problem is, after a couple of minutes, the screen starts turning really red, almost like there's no green anymore. It's like one of the colors is just being drowned out. So looking at this now, you can see how it's starting to turn purple, and that's no bueno. Okay, so let's go ahead and turn this on. Just turning the potentiometer down a little bit. Okay, we're starting to get a little bit of that purple again. So I'm going to let this kind of go for a second. And during the time that I'm going to let this go, what I'm going to do is I'm going to go over to my menu thing here. And we're going to go down to geometry. And we're going to go to the clamp settings. And you'll see that right here we got 90. Well, I'm going to increase that. I'm going to go to maybe like 100. And the clamp SP needs to be higher than that generally. So we're going to go to like 101. Actually, no, you know something? I'm going to go to 5. Go to 5. And this is, I'm going to go to 4. let's see what happens with this. We got that line up here. I'm going to go back to the menu and see if I can get rid of that. That would be once again in geometry, horizontal position more than likely. There we go. Everything else looks okay. Oops. Right there, revenues. That's what we're looking for. Alright. And we come up here to the main picture. Brightness. Let's give this about 10 or 15 minutes and see if it ends up turning the pink hue or whatever. Looks like we have a winner, so now I can go ahead and build a frame for this to put it inside the machine. Okay, well, I've got the game up and going. Everything seems to be working, whatnot. I ended up putting a frame inside there to hold the monitor, and I just ended up using some scrap maple that I had, and then from there I cut out a piece of black poster board to tape around it for like a bezel behind this bezel, so it's not like an eyesore, because this is curved to show the for the CRT. But everything on this works, and needs to be cleaned like really bad though. Did you want to give this a shot, dude?
Oh, okay. Come on over, buddy.
Alright, so you have to get like
Where's the gas station?
Well, another game repaired. This one was a headache, man. There was all sorts of stuff going wrong with this game that, you know, first time I experienced it and stuff in that monitor, I spent so much time on it trying to get it right, when it was just, you know, parts that weren't supposed to be together, you know. But for future reference, at least I know now in the future, if I see something like that, I know, hey, this is what's causing it. But that being said, everything's good to go, and I can have the owner of this game come by and pick it up. So, which is good. I'm getting tired of looking at it. So anyway, guys, until next time, talk to you later.